Okay, and we have our functions y is equal to 3x squared, y is equal to 0, and x is equal to 3. And we want to determine the volume of the solid generated about the x-axis. And with these functions, okay, with the quadratic function y is equal to 3x squared, y is equal to 0, and x is equal to 3. Okay, we have the following formation, and contained by these three functions will be a triangular region. And for the solid generated about the x-axis, okay, we will look at integration with respect to the variable x. Okay, and since we were looking at solid contact with the x-axis throughout from start to finish between the triangular region, okay, we're going to be able to utilize the method of discs. And now in terms of the vertical slicing that is involved, okay, we have from start to finish the height in the two-dimensional drawing, okay, of this triangular region from 0, 0 to 327. Okay, it's going to be 3x squared, since you're looking at this relative to the x-axis, namely y is equal to 0. And so in looking at what we have for the solid revolved about the x-axis, okay, we're going to have, with a three-dimensional solid, again, think of halves mirroring each other. And giving the figure a little bit of a three-dimensional twist to it. Okay, and the solid is going to be something like a bugle, not a cone in its purest sense, okay, more like a bugle. And so we have, in the case of the method of discs, okay, we take out a disc here, and so for what we have in correspondence to the thickness of each slice, okay, that'll be like your dx, or the thickness of the disc itself. And so we have for the radius that is involved, again, that's going to be the height, top function minus the bottom, so you have the r is equal to 3x squared. And with the method of discs, okay, we can determine the volume of the solid about the x-axis. So we have for v of x, again, integrating from x equals 0 to x equals 3. Then we have pi times the square of 3x to the second. And so for what we have in the follow-through, is that as we square out, okay, we have 9 times pi times x to the 4th dx. And in looking at what we have for the volume of the solid, and in utilizing the power rule of integration, okay, it's going to follow with the antiderivative at 9 pi x to the 5th over 5, as x goes from 0 to 3. Okay, what we're going to have in the result is that as we plug in 3 for the upper limit, okay, it is going to follow that for the exact amount in this particular case, we're going to have, in essence, an amount that is going to be at 2,187 fifths pi.